Section 1.3 is on page 33, talks about properties of trigonometric functions. And if I want to look for the homework on page 44, I'll notice the following problems. What I did, I went on a separate page. I copied down what we had last time. So using trig or geometry. And I'm going to refer back and forth to this page as we do problems. I'm going to start with number 12. I'm going to do few problems. You know what few mean, right? All the evens. I'm going to do every even in this. We want to master this idea. 420 is too big. Coterminal to that, I could subtract 360 degrees. What does that mean? I could do that any time I want. That would be what? That would be the cosine of... So what is that? If I subtract that, that is 60 degrees. So I'm looking for the cosine of 60 degrees. Two ways of figuring that out. Either I look at 60 degrees, cosine is 1/2, or 60 degrees, cosine is the adjacent over the hypotenuse. Either way, that's 1/2. Number 14, if I take the sine of 390, that's too big. If I subtract 360 degrees from that, this is really the sine of 30 degrees. I apologize, normally I work downwards, but I wanted to fit them all in one line. So the sine of 30 degrees, again, either I'm looking at 30 degrees right there, sine is the y, that's 1/2, or sine of 30 degrees is the opposite over the hypotenuse, that's also 1/2. Now you know what, I'm going to work downwards. If I subtract 360 from this, again, this turns out to be the secant of 60 degrees, and the secant of 60 degrees, I have two options. So I'm breaking my own rule. I should be working downwards. I'm debating if I should redo this. That's okay. 60 degrees is right there. And if I want the secant, that's the hypotenuse over the adjacent. Or 60 degrees is right there. Secant is the reciprocal of this, 2/1. Cotan of 7 pi over 4. Pi over 4 is the key. I know that's a 1 because if I take the sine over cosine or cosine over sine, that's a 1. If I take in 45 degrees, the opposite, you know what, I should have shrank this a bit. Okay, there we go, much better. If I take the tan or the cotan, that's still a 1/1. So this is a 1. The question is, where's 17 pi over 4? I have two options. I could go in there and say, well, look, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It was 13. 14, 15, 16, 17 is in quadrant 1. Or I could say, take away 2 pi, which is 8 pi. 17 minus 8 is 9 pi over 4. That's still too big. Another 2 pi. 8, that's pi over 4. I'm in quadrant 1. In quadrant 1, they're all positive. 20. I know this is radical 2/2. Again, I'm looking at the pi over 4. There's the sine. 45 degrees, sine is the opposite over the hypotenuse. Rationalized. The question is, where's 9 pi over 4? I have two options. Either I go in there and I count. 9 pi, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm in quadrant 1. Or I take away from 9 pi 2 pi. That's 8 pi. That make it the sine of pi over 4, which is radical 2/2. 25 pi over 6. Pi over 6 is a reference of 30 degrees. So I know what the answer is. 30 degrees. Secant is the reciprocal of cosine. The cosine is radical 3/2, so it's 2/radical 3. Or, if I look at 30 degrees, there's 30 degrees. Secant is the hypotenuse over the adjacent. Alright? Question is it positive or negative? Where's 25 pi over 6? I have another option. 25 pi over 6. This is a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 pi over 6. Or quadrant 1, or I say, you know what, let's take 25 pi over 6 minus 2 pi. If you take 2 pi away from that, that would be over 6, 12. 25 minus 12 is 13 pi over 6. Another 2 pi, 12, that's pi over 6. (540) is too big. If I subtract 360 degrees, I will end up with a 0. 6 out of 14 is 8, 180 degrees. I know exactly where that is. That's right there. And if they want the secant, secant is 1 over the cosine. And that's 1 over the cosine at that point is a 0. So that is undefined. Yeah, now I'm debating. I should have went with the other. I should have wrote them individually. It's kind of squished like that. I'm sorry about that. And 9 pi over 2, that's too big. I'm going to take away 2 pi. I'll show you two ways of doing that. If I take away 2 pi, that's 4. 9 minus 4 is 5 pi over 2. That's too big. Another 2 pi minus 4, that's pi over 2. So that's pretty much right there. And this is cosecant 1 over the sine. And sine is 1, so that's a 1. Another way of doing that, if you want 9 pi over 2, you could say that's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5, 6, 7, 8, 9 pi over 2 is right there. That's another way of doing that. One of the biggest issues in trigonometry is figuring out where you are, and this is something that's going to help us determine. If they say the sign is positive, remember, all students take calculus, so sign is positive in quadrant 1 and 2. And if they say, oh, I'm sorry, sign is negative, less than 0 means negative, negative in those two quadrants. Cosine is positive, cosine is the x, isn't the x positive in those two, or right there? All are positive and cosine is positive. Which quadrant satisfy both of those? Theta must be in this quadrant. So if you draw the triangle, theta must be right there, always with the x-axis. A big deal. If I look at number 32, it says cosine is negative. Cosine is the x. It's negative in this quadrant and in this quadrant. Tangent is positive. And do we see where tangent is positive? Tangent is positive. All of them are positive in quadrant 1 and in quadrant 3. So which quadrant satisfy both of those combined? The angle must be in quadrant 3. And it looks like this. There's the angle. Always between a terminal side and the x-axis. There's theta. Cosecant is associated with sine. Sine is the y. Where's y positive? In quadrant 1 and 2. Cosine is negative. Cosine is the x. There it is. So that indicates the angle is in quadrant 2, and that means you pick any... Okay, there we go. The angle is always referring to the x-axis. And now we come to the actual work. Now, here I have a couple of options. Find the exact value of the remaining 4 trigonometric functions. Well, hey, look at that. Cosecant of theta is the reciprocal. I don't need to do much. And secant of theta is negative 5 over 3. Not only that, I could say that tan of theta is the sine of theta over the cosine of theta, which is negative 4/3, which means the cotan of theta is negative 3/4. No big deal, really. I could just use that. Here, the same deal. I could say, look, I know what the cosecant of theta is, the reciprocal of that. Well, the only catch you need to rationalize Radical 2 times radical 2 is 2 times 2, that's a 4. And secant of theta is negative 3 over 1, or just negative 3. The tan of theta is sine over cosine, so that's 2 radical 2 over 3 divided by negative 1/3. Those undo each other, that's negative 2 radical 2. And that makes the cotan of theta to be 1 over negative 2 radical 2. Rationalize, that is negative radical 2 over 4. There we go, done. If they give me two of those. If you'll notice, the majority of this section, they don't. The majority, you're only given one of them. And that makes things a bit challenging, because if I use the identity like we did in section K, then it's a problem. Here they tell me, look, theta is in quadrant 4. The reason they tell you that, in geometry, all the trig functions are positive because the angle is acute. You're always in quadrant 1. Here, they're saying the angle is in quadrant 4. You need to draw a rough sketch. The angle is right there. All students take, well, I know all of them are negative except for cosine and secant. Now, they want me to find the remaining trigonometric functions. I only have one of them. Well, guess what? Isn't that the adjacent over the hypotenuse? Isn't the adjacent 3? The hypotenuse is a 5. And how do you find this side? Well, you could use Pythagorean, or 3, 4, 5. You could say 5 squared equals x squared plus y squared. Y squared equals 16. If you're not familiar with that, when you square root both sides, you pick y to equal plus or minus 4, and you don't cancel the negative because y in this quadrant is negative. And if you want to take the sine of theta, that's the opposite over the hypotenuse. And the tan of theta is the opposite over the adjacent. I don't mind on the homework you just listing those 3 because I assume you know how to do the rest. On the exam you list whatever I ask you for. So I'm assuming you could do the secant reciprocal of that, cosecant reciprocal of that, and cotangent reciprocal of that. Same deal on number 46. They tell me which quadrant I'm in. I'm in quadrant 3, which means the angle is right there. And they say sine is, well, sine is the opposite over the hypotenuse. The opposite is a 5, hypotenuse is a 12, but one of those is negative. Which one? It has to be this side. The hypotenuse can be negative because we mentioned that represents the radius of the circle, and the radius of the circle can be negative. Well, again, if you're not familiar with this, you could work it out and say 12 squared equal x squared plus a negative 5 squared. If you know what that is, you could write it automatically. There are a few triangles that you memorize from geometry, and x squared would be, if you take 25 out, what is that? That makes this plus or minus 11, and this quadrant isn't x negative. So what is the cosine of theta? That's the adjacent over the hypotenuse. Oh, it was 13. I lied. I remember that's no wonder I was confused a bit. Kept on thinking, wait a minute. I saw the 13, but I wrote a 12. Okay, that's much easier. So 169 equals 25 plus x squared. There you go. Much nicer. X equal plus or minus 12, and in this case it's a negative 12. Yeah, 5, 12, 13. So cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. And if you run to number 50, the same deal. Here they're telling me the angle is between pi and 3 pi over 2. So you're in quadrant 3. There's the angle. This is the opposite over the hypotenuse. The opposite over the hypotenuse, we know that's a negative. And if I take the hypotenuse squared, that's 9 equal x squared plus 4. X squared equals a 5. X equal plus or minus radical 5. And we know this is radical 5, negative. So the cosine of theta is the adjacent over the hypotenuse. That's not clear, it's a negative. There we go. And tan of theta is the opposite over the adjacent, negative 2 over negative radical 5. That's a positive. If you rationalize, that's 2 radical 5 over 5. And if I get to 52, well, from the information given, cosine is negative. Cosine is the x. It's negative in those two quadrants. Tangent is positive in quadrant 1 and 3. And can you guess which quadrant I'm in? I must be in quadrant 3. That's the only quadrant that satisfies those two cases. So, anytime they give us two different trig functions and their signs, no matter what they are, there's only one triangle that satisfies. And this is the adjacent over the hypotenuse. Adjacent is a negative 1, hypotenuse is 4. And now I know that hypotenuse squared is 16 equal 1 squared, which is 1, plus y squared. Y squared equals 15. And y equal plus or minus radical 15. In this quadrant, y is negative. So the sine of theta would be the opposite over the hypotenuse. And the tan of theta is the opposite over the adjacent, which is positive. So on the homework, make sure you do a couple of those, find all the 6 trigonometric functions. Here, the same deal happens. I'm trying to eyeball where am I, which quadrant I'm in. This says cosecant and sine go hand in hand. Sine is the y, so we're positive in those two quadrants. Cotan and tan go hand in hand. Tan is negative, so tangent is positive in those two quadrants. It's negative in quadrant 2 and 4. So what does that mean? The angle must be in quadrant 2. There's theta. Keep in mind that's over 1. And isn't this the hypotenuse over the opposite? The hypotenuse is a 3 and the opposite is a 1. And how do you find the missing angle? You say hypotenuse squared equal 1 squared plus x squared. 8 equal x squared. X equal plus or minus radical 8. In this quadrant is negative. And isn't that 4 times 2? So that is 2 radical 2. And in this case, I know the sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. And the tan of theta is the opposite over the adjacent. And if you rationalize, one more of those before I get to the last portion of this lesson. See? Yeah, almost there. I need to know which quadrant I'm in, and here we are. Same deal. Cotan is positive in quadrant 1 and 3. Cosine is the x. It's negative in quadrant 2 and 3. So either that or you say all students take calculus. Cosine is negative in those two quadrants. I must be in quadrant 2. There's theta. This is the adjacent over the opposite. The adjacent is a 4. The opposite is a 3. But what am I missing? Keep in mind, in this quadrant, those two are negative. And this is a 5. The sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. And the tan of theta is the opposite over the adjacent. There. Again, I'm assuming you could find the secant, cosecant, cotangent. Now, something that they want us to learn, and it's important to learn this, not for what they need. I could do all of these problems without really using the even-odd property. We need the even-odd property for other things, for graphing, for some of calculus integration. So we need to know that.